Hello everyone. Thanks for watching this video. This video will teach you what you need to know to do Lab 8. And Lab 8 will focus only on one topic, which is transaction management. So, what is a transaction? Hopefully you've done the reading and you have a pretty good idea, but my way of thinking of a transaction is it's basically grouping together SQL statements such that they all need to succeed or they all need to fail. So you don't get into a situation, for example, if you're doing a transaction to transfer money from one account to another, you don't want to run into a situation where the money disappears from one account but is never added to another account. So any kind of financial transactions in which multiple things are happening need to either succeed completely or fail completely, or else money can just disappear. So let me show you an example of how transactions work using our bookstore database. So you'll notice in this book table and this author table we have a relationship from book to book author that is one-to-many. So what this means is that each book needs to have at least one author, and it can have many authors as well, but each book needs at least one author. So how would I set this up in my database so that I would not be able to have a book with no authors? Well, let's first see what's in our tables. There we go. Okay. So I have 3 books and I have 3 authors. Now these 3 books all have authors, so that's good. This book happens to have 2 authors. Now I do have an author here who hasn't written any books, but that's okay, because my relationship from author to book author is 0 to many. But let's say I wanted to add a book for John Steinbeck. What I would want to do is both do an insert to this table to add a book and do an insert to this table to indicate who that book's author is. And I need to keep these 2 tables in sync because I don't want to get a situation where I have a book and that book has no book author record, because then I don't know who the author is. So what would happen if we inserted data without transactions? Well, let's see the problem we could get into. So let's add a new book to our book table. We'll do book ID 4, it's the next value in the primary key. Publisher 1, Grapes of Wrath. Add the year, book pages, and editor we can leave blank. Now whenever we insert to the book table, we always want to insert to the book author table also. So how do we do that? Insert into book author, book ID 4, author ID 3. I believe that's Steinbeck, right? Okay. So if I were to run this code, it would insert a row to both tables, everything would be good. But what if there is some kind of mistake in this code? What if there's some kind of front-end application that someone writes and they make a little mistake in their code, and for whatever reason it tries to send in some kind of string into the book author table? Now it should be sending in an integer here to represent the author ID. But let's see what would happen if we ran these 2 pieces of code at once. Because remember, according to our data model, all books need a book author. So if we were to run this, oops, what did I do? Huh. Which one had a mistake? Oh, I forgot my values. Okay, anyway. Let's say we were trying to run this statement. Okay, now, in this case, our first SQL statement succeeded. We added a book to the book table, but the second one failed because we tried to pass in a string. So, let's see what our tables look like now. Now, unfortunately, we have a book ID 4, Grapes of Wrath, and it does not have a record in the book author table. So we don't know who the author is, and we violated the rule of our ERD, which is each book needs at least one author. So how would a transaction help in this case? Well, first of all, let's get rid of that extra book. Okay, that's back to where it should be. Let's see how things look. Okay, we've got our original 3 books, we've got our authors, and we've got these records here. So now we've sort of reset the system. Now, what if we do the same thing that we did before with running this code, but we start by saying begin tran. So begin tran is how you begin a transaction. You can type it out, transaction, but most people just say tran. And you can name your transactions or not. You could just run this code without a name, but names are helpful if you have many transactions and you want to commit or roll back a specific one. So let's begin a transaction first before we run this code. The idea is this tells the server that everything inside this transaction either needs to run completely or fail completely. So if one of these statements fails, the other should be rolled back. So let's run this. Okay, so first it inserted a row to the book table. Then it tried to insert to book author, but it failed. So if this transaction works successfully, when we look in our book table this time, we should not see that extra book. And you can see we don't. And the only difference between what we did before with running this code and what we did now is before we did not do a transaction. So you can see that's why transactions are important. Imagine this statement was updating your checking account table and this was updating your savings account table. You want the transfer either to work completely or not work completely. You don't want to lose money because one update worked and the other didn't. So that's how transactions work. Now let's go through the steps of doing a transaction. Now before we start, I just want to make sure that transaction T1 actually rolled back. I'm going to try to roll it back and it should say there's no begin transaction because it automatically rolled back when this statement failed. So that's just a check I was doing. Okay, let's look back at our book author table and our other ones. So we have 3 books, 3 authors, 4 book authors. Now, something interesting about transactions is when you're in the midst of running a transaction, before you've committed it or rolled it back, or before it's automatically rolled back because of an error, you will actually see a different version of the data than other people will see who are looking at the database. So let's run the first half of this transaction. Now, did we start a transaction? No, I didn't. Let me start this transaction again. Okay, now let me run the first half of this transaction. Okay, now let's look at the data. So you can see, okay, we've got Grapes of Wrath here. We do not have a book author for it. But what's interesting is, even though we are seeing this row, when we're looking at the data, if someone else were to connect to the database, they would not see this row yet because the transaction hasn't been committed. And to show how that works, I'm just going to copy this code, and when I hit a new query, that's actually going to create a new connection to the database. And now when I run this, you can see that it's actually stuck. The reason it's stuck is because it's trying to read from a table, this book table, that has an active transaction in progress. So that table is actually locked by the database server because I have a transaction open on that table. And that will just keep spinning forever until I either commit or roll back my transaction. Let's go ahead and stop this for now. Now let's run the second half of our transaction. Okay, I think I may, right, okay, that failed, good. So now that transaction is rolled back, so now when I go here and run, I see the data back to its original state here as well. Now let's make this transaction succeed. Let's put in the right value. There's author ID 3. Okay, so it should have rolled back. Let me just make sure it did. Just going to try to roll it back, and it should tell me there's no transaction in progress. Good. Okay, let's go here again. There's our data. And since we are not in the midst of a transaction, when this connection looks at the data, imagine this as a different user. They can see the data. Okay, let's begin our transaction again. Let's insert to one table. Succeeded. Let's insert to the other. Succeeded. Now go over here, and when we try to look at the data, because there's transactions in progress locking the tables, this will never return data until we commit over here. So let's just stop it. And now finally, what we do when our transaction is finished is we say commit tran and then the name. So when we say commit, it's going to take the data that's only in our version of the table that's visible to this connection and make it permanent. So commit the transaction. Now when we go here, we run this query and we see the data. We've got Grapes of Wrath here, and we've got the author here. So that's good. Now let's get rid of those new rows so we can show one more thing. I'm just going to delete from the book table where book ID equals 4. Delete from book author where book ID equals 4. So if I run both of these, I should actually probably run these in a transaction just in case one delete fails and the other doesn't, but just for time's sake, let's just run this. Oops. Oh, I know why. You have to run this one first because of the foreign key. Okay, let's do this. So the reason I ran those last two statements was just to set the database back how it began. So let's run again. And you can see we have our database back to how it was. Okay, now let's begin a transaction. Let's run these two statements. Okay, the transaction is active now, meaning the data is in our version of the table but not visible to other users, and it's locked the table so other users can't see it. Now, you've seen how to commit a transaction. You've seen how to begin. The last thing is, what if you want to roll it back? What if you decide, oh, I don't want to do this after all? Now, if there's an error in any of this code, it will roll back automatically. But if you want to manually roll something back, you just say rollback tran and the name of the tran. So now, what's interesting is, you see how this is spinning, it's waiting, it's waiting. Well, in this connection, I'm going to roll the transaction back. And as soon as I roll that back, now it's visible here. So let's just run this again and commit it. Let me make sure the data is at the beginning state. Good. I'm going to change this to commit tran. Okay, so let's begin a transaction, and we'll do the inserts. Okay, and before we commit it, we'll come over here and try to run these queries. Again, they don't finish because this user here cannot see the transactions that are in progress, and the tables are locked for him. Now when we hit commit here, now we've committed the changes to the table, and now this user can see the changes. So transactions are a fairly simple concept when you implement them, in that it's just basically begin tran, commit tran, and end tran. But they can get a little complicated if you've got nested transactions, like transactions inside of other transactions, because sometimes you don't know how many levels deep you are and you forget what's active and what's rolled back. But transactions can be pretty simple. In our case, we just have one transaction that has two insert statements. So this is really all you need to know for the lab. If any of this was confusing and you're having difficulties with the lab, please don't hesitate to contact me. I hope this was useful and that you learn a lot about transactions this week. Have a good week.